There's been a lot of debates about what we're doing in space and how we're going to get there. There's great potential when we push ourselves to do the impossible. My name is Porterfield. I'm a professor here at Purdue University in agricultural and biological engineering. I'm optimistic we can do it. We are going to have to go out and explore into deep space, and we're going to have to tackle some major challenges in terms of our life on the planet here before we can actually be successful in that new venue. We're going to be extending missions onto the moon into deep space. So this is a new era in space exploration. Over the last 20 years, we've really been kind of in a holding pattern in low Earth orbit. And low Earth orbit is not deep space because we're actually still within the Van Allen belts. So the medical and biological problems we're facing in low Earth orbit can prepare us for microgravity, but not for the radiation challenge going into deep space. And that's part of our focus for what we're trying to accomplish with the LEAF mission on Artemis 4. My group is really focused on the engineering of bioregenerative systems and habitation systems to keep humans healthy. Bioregenerative life support is really an approach that would integrate humans with agricultural production, bioreactors, and other systems where you could basically have an ecosystems approach. We're closing the atmosphere, the fluid loops, food and nutrition. We need to understand where all of our vitamins come from in ecosystems and how that all loops together, because we can't go out there and leave a part out. We need to be able to complete these complete ecosystems in terms of the human nutritional model. Food production, waste recycling, all that driven by biological engines that we know we can develop here on Earth, but they're going to have to perform in deep space. At the same time, we're focused on developing specific technologies to solve problems. We've been developing cultivation and biotechnology production systems. Right now we're actually producing lovastatin and other commercial pharmaceuticals using mycoponics. We're able to recover the exudates from the mycelium, so it's a novel pharmaceutical production technology that we're actually commercializing here on Earth, but also we're planning on enabling that as the astropharmacy for the future. With mycoponics, we can actually grow 18% of the existing FDA-approved pharmaceuticals right there on the moon. So we're actually enabling these technologies that will, basically move these bioproduction systems out to the frontier. Ultimately, it comes down to the technology we need to enable humans to explore deep space and really move out is the same technology we need to save the Earth. To some extent, I've been dreaming about this ever since I was a little boy. Actually, there was a TV show that came out in 1976 when I was 10 years old called Space 1999. And it was about a moon base. And that really represented in my mind what humans are going to do next in space. We're going to have to move out to the moon and then move beyond there. So this really is the next step. We're working to make science fiction into science fact here at Purdue.